Willkommen zum Nick Does Maths. There's some maths. Let's have a look at it. We're still staying away here from like the heavy further maths content, but we're still going to push ourselves in the way we interpret everything. We want to start just by sketching y equals a plus x over a minus x. Fairly innocuous, which makes me feel like there's a trap coming later on in the question. Now, we could just do the division, but I know this is a reciprocal graph. You could play around with it a little bit. Looking at this, I should have an asymptote at x is a, something else. But there's a nice way to do this. Let's try and get the top as some multiple of the bottom. So I've got plus x and minus x. So I'm going to write the numerator as minus a minus x. But then I have x minus a. I want plus a. So I'm going to add a 2a onto that. So that gives me minus 1 plus 2a over a minus x. Nice, because now I can view this as a transformation of a 1 over x graph. I'm going to get an asymptote at y is minus 1. I'll get an asymptote at x is a. It's minus x, so it's going to be going the wrong way around. Something like that. When x is 0, we're going through 1. So that's kind of nice. First things first, that is my graph of a plus x over a minus x. I wonder if it'll come in handy later. Back on camera. I was off on an adventure. Right, meat and potatoes of the question. We have this semicircle here. You got this semicircle. We've split it up into part A and this part B, which is the rest of it. Now, part A is delineated. The edges of A are at minus cos theta and sine theta. Okay, that's where they are. Now, first of all, can we find an expression for the area of A? We could get integrating, and I'm sure we'll get something nice, but we've got sine theta and minus cos theta. So let's see if we can visualize this any differently. So I'm just going to get rid of this. I'm going to try and recreate this in a diagram a little bit bigger. Oh, look at that. Look at that. Now then, this is a circle radius 1. So one thing we could visualize here, doing it A, right? So let's get some of this. Because that's radius 1. So if that's minus cos theta, that angle there is theta. Just by virtue of that's how right angle triangles work. Because that's cos theta, and that will be sine theta. And in a similar way, let's use some green here. Now, if that length there is sine theta and that's 1, that tells me that angle there is theta and that side there is cos theta. The real funky thing that happens once we visualize this is that that is a right angle. That there is a right angle. Now, that is a quarter circle, a circle of radius 1. So that area there is pi over 4. The blue area, well, we'll just do triangle, right? Half A, B, sine C. And the green triangle is half AB, sine C. So the area of A, this tells me that the area of A is going to be pi over 4 plus this. Now it's a half cos theta sine theta and a half cos theta sine theta. So that is just cos theta sine theta. Okay, I can take that. That seems nice. Let's put a condition on sine theta cos theta. All right, so that's part 3. Now, whenever I see a product of two things and an inequality, it makes me want to go look at something like this. So I could have a look at sine theta plus cos theta squared. Now, that is strictly positive. Now, why is this nice for me? Because sine squared plus cos squared theta plus 2 sine theta cos theta is positive, and that's 1. Okay, that is the wrong way around for me, because that would give me sine theta cos theta is bigger than something. So that's not what I want, but this is fixable. This is fixable. What if I change that to a minus? That and that stay the same. That becomes a minus. That becomes a minus. And at this point, sine theta cos theta is in fact less than or equal to a half. Very nice. Okay, let's keep going. Let's keep rock and rolling. So we got this condition. This is my derivation. I'm going to get rid of this because we just need this result. Right. Now, can we find the maximum ratio of A to B? So how do I maximize the ratio of this area to that area? Right, so I need to find how much bigger can I make this area than these two by changing theta. Now, the area of B is quite straightforward. It's the area of the semicircle minus A, which in our case here is that. So we end up with pi over 2 minus pi over 4, which is pi over 4 minus sine theta cos theta. Well, that's funky, because then A over B becomes pi over 4 plus sine theta cos theta over pi over 4 minus sine theta cos theta. What do you know? That's what we played around with up here. Right, because all we've got here is we've got A is pi over 4 and X is sine theta cos theta. Okay, well, what do we notice? Right, so X. What's the biggest I can make sine theta cos theta? Well, in my previous one, I've said the biggest I can make sine theta cos theta is a half. So in fact, if I go to my graph here, the biggest I can make sine theta cos theta is a half. And this is my sine theta cos theta axis now. All right, let's not worry too much about theta, but we're going to say, well, the biggest I can make sine theta cos theta is a half. So the biggest value of X I can get is at a half. And that will give me a maximum value of Y, because you can see that your Y value here, which is all of this Y value increases all the way up to here, which is at sine theta cos theta is a half. So my maximum value of this is pi over 4 plus a half over pi over 4 minus a half. And if I multiply top and bottom by 4, I end up with pi plus 2 over pi minus 2. Pretty cool little question, this one. Pretty nice. Et voila for you, minions. Really cool. Completely looking like separated part A, but actually it comes in and plays with us. Bear in mind, at no point did I differentiate this with respect to theta. That would have been a headache, and I don't want a headache. All right, but I used the previous parts of the question and tried to spot the links between them, which ends up making this quite trivial. Awesome. Don't forget to like, subscribe, hit the bell for notifications. We're going to keep coming at you with these cool little maths questions to start us off this academic year, keep the brain ticking over, see how we go. These are very accessible in terms of the maths content, so come check them out. If you enjoy it, keep tuning in. I'm going to keep doing these. See you next time.